Section 7.5 is going to basically combine what we've talked about this whole chapter so far.
All right.
Okay? Notice the title says Glide Reflections, which you can probably make a prediction what that involves. We'll talk about that first. And then we're going to talk about what a composition is.
Okay.
What a glide reflection is basically a combination of a translation, there's your glide part, and a reflection that are performed one after the other to produce a single transformation. So it's basically a combination of two transformations to make one complete transformation. Okay. Now, the way that when you do this, all right, and this kind of in blue is kind of important for you to understand. It says as long as the line of reflection is parallel to the direction of your translation, the order will not matter.
Okay, so that means that I could first reflect, then translate, or I could first translate, then reflect. But only if the line of reflection is the same as basically the direction that my translation
So like
is.
if and we're going to do a specific example. If the line of reflection is, let's say, a vertical line, what direction would you have to go in order for the order not to matter?
I would have to go...
What direction would the translation have to be?
Oh, it would have to be parallel to that. So it would also have to be going up and down.
Yeah, so you would either be going in a downward direction, so your vector could be going down, or you could be going up for these to be parallel.
Okay.
So one rule of thumb that I often tell my students is, if they tell you to do the translation and then the reflection, I would do it in that order.
Right.
But they might ask you a question where will
Would
the
it have
order
mattered?
matter? And explaining it would be, maybe something along this line. Just a little hint on that aspect, okay?
Oh, like you might see that later.
Yeah, maybe, possibly.
Wink, wink. Okay. All right. Compositions are when you have two or more transformations that are combined to produce a single transformation. We just talked about the idea of a glide reflection. That is a type of a composition. It's a specific type of a composition where you're going to be doing a translation and then a reflection, but it works for a composition, just saying for anything. So I could rotate, then transform. I could, or translate. I could rotate, then reflect, or reflect, then rotate.
You could reflect, rotate, translate.
And translate, yeah. So it's just putting them all together, okay? The order may affect the location of the final image. So what I think Ms. Palermo mentioned already and what I tell my students too, the order that they give them to you, go in that order, all right, just to be on the safe side. And compositions are isometries, so your final product should be congruent to your original pre-image.
Okay.
But yeah, make sure you're just going in the order that they give you. I think that's always a good rule of thumb when you're working through compositions.
Okay, so what we're going to do is we're going to perform several compositions. Some might be glide reflections. Some might not be. But one thing you're going to notice is the directions are going to ask in a lot of these. And like, notice this one. It says sketch the image of triangle QRS. All right, now this is the pre-image.
Right.
Okay. They're wanting you to sketch the image after this composition. So basically, your final answer is after you translate and then reflect. Okay. And we're going to stick in the order they give us, mainly because we're not really sure if the order will matter. We're going to ask that question in just a minute. We're not going to perform it reflect and then translate to see. We're going to know based on what we just saw on a couple slides ago. Okay. So we're going to do the translation first. Now, after I translate, is that my final answer?
No.
No, because then I got to reflect. So we're
Yeah,
gonna have
otherwise
to
it's not a composition.
So basically what you're going to want to do is basically do the translation first, like I said, then go ahead and reflect. And in the process, I'm going to ask you to give me the coordinates after each time you do something.
Okay. Sounds good.
So if I wanted to translate, let's start with point Q.
Okay.
And they give you coordinate notation here. So what would I have to do?
I noticed that the X value is not changing. So it's not moving right or left at all.
Okay.
It is just moving up 5. So I'm going to take Q and I'm going to just go up 5, which puts my point at 2, 2. That's Q prime.
Now, you could even, keep in mind, because they just said sketch the image after this glide reflection technically.
Okay, so really I don't have to graph that.
No, you could have just gone, okay, well, all right.
I'm just
And I
adding.
noticed you said that the x's stayed the same. So notice it's still 2. And then she said up 5, or in other words, you could say plus 5. So there's where you're getting the 2.
Right.
Okay. I personally sometimes encourage students to graph each time because then it's an easier thing to have a visual of it.
Well, and I think translations are one of those that are easier to just write the coordinates of. But if you don't remember all of the rules that and all the patterns that we've discovered before, it's not going to be easy to do the other things.
Yes. So it's nice to have it.
Yeah.
All right. So we're just going to move all of these up 5. And you can also, again, get the ordered pairs without doing this.
Right.
So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5.
All right. So S prime. So you ready to write?
Not the best triangle.
That's all right.
Okay.
Is at 5, 4. And R prime was at 4, 1.
And if you notice, okay, it didn't change the x.
Nope.
I add 5 to this. There's where I'm getting the 1. Don't change the x. Add 5 to that. That's where you're getting out. This is not my final image, okay? This is just the image after just the translation. But it's
Kind of our in-between image.
Okay, so now, okay, so this is not my final answer. This is more like a check through, okay, like this is where I'm at so far. So we've already done this. Now let's go ahead and reflect. Now notice they tell you the line of reflection. So we need to understand what the line y equals -2 looks like.
All right, well, we know that's a horizontal line.
Okay.
And I know it goes through the y value of -2. So if we go down to that y value of
I
-2.
thought I changed the color, but I guess not.
That's all right.
Oh, well.
So there's our line of reflection. So now I remember when we did reflections, we had to kind of see how far these points were from the line and just continue it beyond that line.
Okay.
So for Q, if I look at that one, it's, let's see.
Now, am I going to reflect this point
Oh, no,
Q,
sorry,
or am I
Q
going to
prime.
Q prime?
Q
Okay,
prime.
so I'm going to reflect Q prime, and you said kind of counting.
Yeah, kind
since
of
this
the
is
line.
horizontal.
So 1, 2, 3, 4 spaces to get to the line. So I need to go down 1, 2, 3, 4 spaces.
Now, how would I label it?
Well, I've already got a Q prime, so let's go with a Q double prime.
I like how you said it, Q double prime. Just 2 little prime symbols there. And if we give the ordered pair, now this will be the final image
Yes, that would,
of what my pre-image of Q is.
yes.
So Q double prime is what?
2, -6.
All right, so we're going to do that for each of those.
Okay, so for R, we have to go down, let's see, 1, 2, 3. So down 1, 2, 3. There's our R double prime, and that is at 4, -5. And for S double prime, let's see, we need to go down 1, 2, 3, 4, 5, 6.
Oh, yeah, sorry.
So then we're going to go down 1.
I'm having such a bad angle here. There's too many counting. Okay,
That's
so
okay.
1, 2, 3, 4, 5, 6.
To get to the line, so we're
Okay,
going to go down
1, 2, 3, 4.
5,
Sorry,
6. It froze on you now?
Yep, sorry.
That's all right. So
Right
there's
here?
our 6. Yep. So there's our S double prime. All
So
right,
S
and that
double
point
prime.
is at 5, -8.
Now, the other thing you could do, and again, this is why I think having the sketch of the in-between image here, the Q prime, R prime, S prime is nice. But you could also just, kind of look at, notice again, because you're reflecting over a horizontal line, notice what stayed the same.
Yeah.
The x coordinates. So the x coordinates never actually changed on any of these.
Right.
Okay, because you didn't move left to right with the translation. And reflecting, you're just moving down in this case. Because
Right.
you're reflecting on that. So that's something to kind of notice as well. All right.
Okay.
Now, question. Would the order matter here? So I'm going to add, will order matter?
So what you're saying is, could I have reflected first and then translated?
Exactly. And
All
we're
right.
not going to actually, I don't want you to actually do that because There is a way to know that. And if you think back a couple slides ago,
Uh-huh.
the order won't matter as long as the line of reflection is parallel to the direction of the translation.
Okay.
Okay? So the line of reflection is
A horizontal line.
horizontal, okay? And what's the direction of the translation?
It's vertical because we moved down. Or moved.
We
I
moved
forgot.
up. So
Up 5.
we went up 5, but our line of reflection is horizontal. So are
they're
those
not parallel.
No.
In fact,
so
perpendicular.
So will the order matter?
Yes, it will.
And the reason why is because your line of reflection
Is not parallel to the direction of the translation. Okay, so just that's kind of a quick check. And guys, if you think about it, if I had first reflected that blue image right over the line and then moved it up, I would be above that line of reflection. Where here, obviously, my final image is below that line of reflection. So you can do that just in your mind and get a visual of where that would be. And that may be helpful too.
and knowing kind of the explanation, I'll tell you this
That's important.
is important. Don't just say yes, well, because it was
Would
a
be
different look.
different.
It would be different. Well, we could see that, but you need to support it with kind of this backing in this way. Okay, so it takes some time to do a glide reflection, but it's just a combination of something we already knew, translation, and something we also already knew. And it's just doing one after another and just being very careful after each of them. Okay.
All right. And for each of these compositions that we're going to be doing, you're going to be doing the exact same idea. You're going to be performing one transformation after another transformation. And sometimes you'll have multiples. And we'll be using the prime symbols to kind of represent just our middle image, and then we can use the double primes for our final image when there's two things that we're doing.
Exactly.
Okay, so now we're going to go ahead and sketch the image of segment CD after a composition. And we've got CD on our graph already. And it says that we're going to first reflect in the x-axis. Now, again, x-axis is going to be this, let me just kind of highlight it, this axis right here. So we want to first reflect, and then we're going to rotate. Okay, so let's start with our reflection. Where would point C be if I reflected across the x-axis?
It stays on that same point.
Yeah, because we know that when your point is on the line of reflection, it doesn't change. Okay, what about D?
Well, you're going to count. So it counts 1, 2, 3. So down 1, 2, 3.
All right, so there's our D prime. So this is our kind of middle image, right? It's not the final image. I'm not done because I've only done the reflection part. I also need to rotate. And I want to rotate 270 degrees counterclockwise about the origin.
Should we write down the ordered pairs?
We
off to the
should.
side?
You're right, because I was going to do them all at the end, and that would be almost silly because then we'd have to go back and look
Yeah,
for
let's
them.
just write down. And one thing, guys, the reason why I point that out, because I was going to say this, is that if you remember the different patterns, and again, it's remembering them. We're not always going to remember them. But if you remember them, knowing the patterns, you could easily write down these ordered pairs too.
Exactly. Okay, so next we're going to go ahead and do our rotation.
Okay.
And we're rotating 270 degrees counterclockwise. So it doesn't matter what method you want to use. We're just going to kind of just talk in general. But if I had said this is the top of my paper, if I wanted to find my new top, counterclockwise, I know I'm going this direction to the left. So here would be 90, 180. This would be my 270. So like if I wanted to call that top, I could, and then get the idea from there. Or if you just want to turn your paper the other direction and see how you get there. What method you use won't matter to us. But looking at where C prime is, where would C prime be, or C double prime be located on this graph?
It would be at what, 0, -2?
0, -2. And what about D double prime? And you could either go off of the pattern that you see, or we could go ahead and do that point D as well.
D double prime is going to be what? Negative, or no, -3, -3.
-3, -3. And again, we can draw in that line. Now, sometimes the rotations, again, they're the little bit trickier ones sometimes to think about. You might want to go ahead and draw in just to make sure that, okay, If I check from C to C, or C double prime to C prime, it's definitely rotated, I could say 90 degrees clockwise, or I could say 270 degrees counterclockwise, and I could check that with D as well, D prime and D double prime. All right, so these would be my final image, my C double prime and D double prime for the image of CD.
Okay.
Okay.
Okay, now guys, we've done 2 already, compositions. I'm going to encourage you just to kind of pause this for a moment, and I want you to try this on your own. I want you to think, can you perform this composition? And it's kind of like the last one, you're performing a composition of a segment. So hopefully you're doing that. Okay. Now, what we're going to do, they already had the pre-image sketch for us, so that's kind of nice. We're going to rotate first 90 degrees clockwise. So here's your amount, direction, and about the origin, which is our fixed points in our rotation. So we're going to do that first. Then we're going to translate, and notice they gave you a coordinate notation of that, describing where you're going, okay?
Well, 90 degrees clockwise, this is just like the 270 degrees counterclockwise.
It is. Now, I want to stress, it just says state the coordinates of the image after this composition. So does that mean we even need to graph this?
No, we don't have to.
No, we don't.
It may be helpful, and especially, like, I think rotations, it's helpful, but maybe I don't need to graph the final translation that happens.
Exactly. So I'm just pointing out, when it says sketch the image, we want to use the graph. If it doesn't say that, if there's a way you can do it without, that's fine, okay? So we're going to, let's just start with E, alphabetical order. So if I rotate that 90 degrees clockwise about the origin, where would you end up?
That would be at 5,3.
Maybe I'll pick a color that shows up a little bit nicer on here. So this would be E.
That'd be E prime.
Okay, and if you need to, kind of just to get a little check in here, is that going to be a 90 degrees clockwise?
Yep.
Looking good.
Looks good.
All right, let me get rid of that. So E prime, I'm going to write down that as coordinates. You said 5,3. All right, what are we getting for F prime?
We would be at 7, -2.
All right, let me sketch the actual segment just so we can have a visual of that. Again, if you need to connect it to the center of rotation to see that idea. Okay, now this isn't our final image.
Nope.
Now we're going to translate. Now, we could technically, because it doesn't say sketch, let's try that. Let's try not sketching this. And we can then check it and sketch it after, but if
and
we're
I think translations are usually the easier ones to not have to sketch.
So what are we going to do to E prime to get E double prime?
Okay, well, I know I'm going to take the X value and I'm going to subtract 3 from it. So my X value is going to be a 2. And my Y value, I want to add 1 to it, so that's going to be a 4. Easy enough.
And basically do the same thing to this one.
Right. So then we'll have a 4, -1.
And if you wanted to sketch it to kind of get a visual, there's your E double prime, F double prime. And if you didn't do it by kind of more subtracting and adding here, you could have gone, what, left 3, so 1, 2, 3, and up 1. Same deal.
Yep.
And notice all 3 of the segments that are in this picture should be congruent.
Right.
Because it's a composition is an isometry.
Awesome. Okay, so now we're going to get into describing the compositions. And that's where it's a little tricky sometimes to see some of these. I would say sometimes the rotations are a little trickier than others, just to identify or to be able to describe them. But we're going to figure out to get from one image to the next. And notice we've got an image that has no primes with it at all. So what is that?
That's the pre-image.
The pre-image. We have one that has just single prime. So that would be kind of our
in between, kind of what we do after the pre-image.
Exactly.
So it goes from the bottom left one to kind of the middle one there.
And then the double primes obviously is going to be our final image. Okay. So starting with triangle MNP. Okay. What am I going to be doing? If you look at the blue one and the red one, what does it look like I did to get from the blue to the red? Am I just sliding it?
No, and I like that you're kind of thinking, am I translating? Am I reflecting? or am I rotating? So
Right.
those are kind of, that's, I think
Those are the questions you
that
ask
to me
yourselves.
would be the first thing you ask. And it doesn't look like you're just sliding it. So translation would be out of the question.
Okay, and now the next thing I usually think of is, am I just reflecting those points?
It doesn't, I mean, it doesn't like reflect nicely. Like things aren't going to match up exactly. So I'm thinking it has to be a rotation.
And it is a rotation, you're right. Okay, so that's the first thing I would narrow down, all right? And we're going to go ahead and start with, it is a rotation. Let me get a different color.
And while she's writing that, when you're doing this, when you're describing each type of transformation in this rotation, we need to make sure we know, okay, how many degrees we're rotating, what direction, clockwise, counterclockwise, and then what point are we rotating it about.
Exactly. Okay, so let's start with that. Just looking at this, if I go ahead and draw in that segment, oh, probably shouldn't use yellow here. That's okay. That connects the image, or sorry, the pre-image to the center of rotation. And I'm assuming that the origin is, but by doing this, it kind of helps to see that, yes, the origin is. And then from that center of rotation all the way to our image, what do you notice about that?
It forms a straight segment.
Yeah.
So it's going to be 180 degree rotation.
So it's 180 degrees. Does it matter which direction we go then?
No, but let's just put CC for short.
Okay.
About the origin. And guys, the origin is probably the most common, as you've seen when we've done rotations, is the most common center rotation. It's not the only, but it's the one we're going to use the most.
And if you check other points, you'd see the same thing, that it definitely does rotate around that center.
Now, another thing you could have done is, when I've shown, is maybe pick the coordinates. So like, let's say point M is what, -3, -2. And then M prime is 3, 2. And I'm noticing the X coordinate and Y coordinates are just opposites. And that's a pattern of 180 degree, doesn't matter direction about the origin.
Right.
So knowing that can be helpful too.
Exactly. Okay, so we know that the first thing that's happening is we have a rotation. Now, the next question is, how do I get from this N prime, M prime, P prime to our double prime figure? Now, if you look at this one, does that look like we're just sliding it?
It does.
It does. What do we call a slide? What's our formal word there?
Translation.
So we're going to translate.
So the first thing, again, is to narrow down what type of transformation and then describe it.
Right. Now, with a translation, how do we describe it?
We can describe it using coordinate notation or component form.
Yes. It doesn't matter.
Doesn't matter.
But
okay.
you just have to pick one.
Okay.
So which one do you want to do?
Well, let's just do both just for checking
I think that
purposes.
sounds
Let's start
great.
with coordinate notation.
Okay.
So X comma Y, and then maps to, so the arrow. And then, okay, so I'm just going to look at M prime and then M double prime since I already have that. And I noticed that M double prime is at 1, 6. I'm just going to look at the coordinates real quick.
Gotcha.
And so basically I went down 2 on the x's, so it would be x minus 2. And then for the y, I have added 4 to it, so it would be y plus 4.
Okay. And we can just look at the coordinates. If you wanted to, you could have counted and said, okay, we go to the left 2 and then up 1, 2, 3, 4 to get to those points. Either way is going to be perfect.
And I'll tell you guys, the reason why I'm not counting, I'm having a hard time. I'm far away from the screen, so it's a little easier for me just to look at the coordinates and not have to worry about counting the spaces.
Yes. Now, that's one way we could have done it. We could have also done the component form. What would the component form?
So it has those brackets, so it'd be -2, 4. And then the bracket.
Typically, you're going to see the coordinate notation when we're talking about doing a composition, but just want you guys to realize that component form also works. Awesome.
Let's do another describing, because I think this gives you a good kind of practice with just using the different description words and things like that. All right, so we are starting with the pre-image, which is triangle ABC, the one without the prime symbols. And we're going to go to which one first?
The red one first, because that's got just the single primes, and then the green will be the last one because that'll have the double prime.
Okay, so let's narrow it down. Is this going to be a translation, reflection, or rotation?
All right, it's not just sliding up to get from the blue to the red. So I am going, but I'm looking at it, and it is definitely a reflection.
Okay. So again, first decide what type and then describe it a little bit more. Now with reflection, all I need to know is what's the line
The
of
line
reflection.
of reflection. Okay, and I'm looking at that, and obviously by looking at point C, it kind of almost gives it away. Because whenever you see a point mapped onto itself, that only happens in a reflection if it's on the line of reflection.
Okay.
So that line of reflection is the x-axis.
Now, another way of saying x-axis, and I only say this because I know that our book does this sometimes, as well as common assessments have done this. X-axis actually has a line, an equation to it. What is that?
Y equals 0.
So we'd accept either one, but just get comfortable with that.
Yes.
Okay, so that's the first thing we're doing. Our second thing we're doing is we're going, and again, we're going from the image that we just got to get the final image. So we're not starting with the pre-image now. We're going from the red to the green.
Right.
Okay, so the first thing I ask is what kind. So is it a translation, reflection, rotation, what? What are you thinking?
That one is a translation because that is just sliding my triangle right on over. And we could either count or we could do the points. It doesn't matter.
Whatever's easiest for you.
Yeah, and
You're
since
closer to the screen.
I'm closer to the screen, and since we did the coordinates last time, this time we'll just go ahead and count.
So which points
So I'm
are
going to
you
do
going?
A prime to A double prime. And I noticed that to get from A to A double prime, we're going over
How many? To the what? Over what?
to the right. So 1, 2, 3, 4, 5, 6. So that's a positive 6.
Okay.
And then we're going to be going up 1, 2, 3. So we could do the component form of 6, 3.
Oh,
Sorry. Or the coordinate notation of x comma y maps to x plus 6 and y plus 3.
so either one. Now, so what we're looking for when you describe, we're looking for what type and the criteria that goes along with that type.
Right.
Right? With a rotation, that's the one that has a little more. So notice rotation, there's a lot more you had to write. Okay, translations, it looks like a lot more, but you just need one or the other. And reflection is just
What line.
What line.